Hello everybody! In this episode we're gonna learn about some new stuff. We're gonna integrate the player movement, the collision system, and of course the camera. So we will do some coding today. Let's get ready. From our last episode we did import our art atlas and our player. And we just created the box collider and put them in the tag of a player, layer player, and adjusted the sorting layer. Just to reconfirm, the sorting layer is basically for sorting, as it says, whereas the tag is basically like you have something put on your forehead saying you're a player, your box, your wall, etc. Whereas the layer, it's basically takes care of handling physics. So if we gotta use any kind of casting, detection of layering, so this is your guy. Right. So the first thing we need to do, we need to figure out how to make the player move. So we're gonna take care of player moving left and right, up and down of course, and flipping to the other side. Whoops, like this. Apart from that, we're gonna work on having the camera follow the player whenever he moves. And we're gonna describe the camera mechanics after we do the player movement. So first of all, we need to start doing the script. So before doing the script, let's create a folder called scripts, just to make everything neat and organized. And create a C# script, call it player. Again, you can name it whatever you want. Let it compile. Afterwards, just drag and drop it. You can drag and drop it in here after selecting player, or just drag and drop it on the player itself. You will appear here. So if you double click this one, you will enter Visual Studio, and then we're going to start doing some code. It's going to be quite simple. We're just going to take the X and Y axis movement of the player and then apply it and then use the physics. Let's remove all the stuff. First of all, let's make it. With every script you have to make sure to have at least two groups. First of all the variables and then the methods or the functions. And the methods there consist of two types of methods. The mono behavior, which is Unity related, and your own methods. But again, as a starter, we're going to do this one. Let me just get this done here. So first of all, we're going to make sure that we have the proper variable. And by variable, I mean whatever going to affect the player itself. So first of all, let's just make something called, I would say, movement speed. And whenever you do variables, you would instantly go make probably public. That would be your first instinct. And it's good, but at the same time, it's really bad. When you start working in a bigger game and then a bigger team, you need to limit your access for the variables just to avoid any problems. So I would suggest using private. Let's call this move speed, right? So you'll say, how can I access this from the inspector? It's quite easy. You can just go one step ahead and write serializable field. So this will make sure that you will be able to see it in the Unity inspector, but other scripts will not be able to access it. So that's been said, we'll start doing the methods step by step. Since we're going to be dealing with physics, the best approach is to have a fixed update. It's one of the updates. You have a fixed update, there's manual update, late update, and normal update. So you can read the documentations about them, but usually it's a fixed update is used for every 1 second of a frame. So it's better, it's the most used, or actually the advised one to be used by Unity when you're dealing with physics. So let's do void fixed update, and it will autocomplete this one. That's great. First of all, you can put all your script stuff inside, which is not a big deal. But for me, I like to have everything separate. Like if you want to deal with movement, you will write them in here, like you do the stuff inside. And then you want to deal with collision, you do them in here. And then it just keeps on piling up. So better what to do is, let's make another method, call it private void move, let's say it's called movement, right? Again, you can call it whatever you want. And let's just call the movement from here so we don't have to worry about anything. First thing we have to do in movement, I'm going to explain it in comments, is get the input. So basically it's the X and Y. Whenever the player clicks the left side, right side, up or down, depending on the arrows or the WASD. After we get this one, we need to cache it. What I mean by cache it is, get the X positions and the Y position and then put them in a vector. Cache it in a vector. After we cache it, we're gonna apply it. But before applying it, I would like to do this thing where we're gonna flip the player according to the move direction. So if you're going right, he's gonna look right and then he's gonna go look left. After that, we're gonna handle the collision. So before we apply the movement, we need to check if he can move. So if he cannot move, he's gonna stop walking. So we're gonna go collision check, and the easiest one would be inside the collision check is apply the movement after the previous check. So these are the main headline of the stuff. Now first of all, what we need to do is to get the raw access, and that's easy. So we just get input. Let's call this one. I don't know. It's just so many naming. So let's just go with move x equals input that get access raw horizontal. And of course I'm going to get an error because this is type of, as you can see, it's type of float. So let's just make sure that this is float. I would assume that's going to come as an integer because get access raw basically gives you -1, 0, or 1. It doesn't care about the decimals between those stuff. So that's what we need. We'll use this one for the x values and then move y for the y values, which is going to be vertical. If you don't know what this is, you can go back here and get inside the input manager in the projects. You can go edit and then project, go into input. Where is the input? Can't see it. Here you go. And you can see here some two things called horizontal and vertical. These are built by default in Unity. You can go left to right, or you can go A or D. Same goes to the vertical, down, up, S and W. So it's quite common. So now we got the inputs. We need to save them in some sort of a vector. So we're going to go and make a vector too. Let's call it move delta. So move delta is basically how much value do you want to apply to the player to move towards it. So new vector, and we're going to go ahead and make move x and then move y. We're going to work step by step and apply changes along the way. So now we have the move delta. We need to apply some sort of flipping mechanics. So I think I did demonstrate this in a bit. So we have our player. In order to flip him, I mean, you would think of this one here, sprite flip, but I'm not going to use this one because when you sprite flip, it only flips the image, it doesn't flip the game object, but we need to flip the game object in order to get the proper directional. So if you flip the object, the right will always remain right. Whereas if you flip the whole game object, the right will become left. So we want to keep consistent because we're using physics. So it's quite simple. We're going to just affect the x scale. So if it's going right, it's going to be 1 and vice versa. How can we get the direction? So it's quite easy. So we can either check the move delta x value, or we can just check the move x itself. So let's just go, incrementally. So let's go and check if move delta x is bigger than 0. So that means he's going to the right side. We just go ahead and transform the local scale equals new. I'm gonna write it fully, so we go 1 by 1 by 1. So that means keep him looking to the right. Else, we go transfer the local scale equals new minus 1, 1, and 1. So you need to, whenever you apply any kind of conditionals, just make sure to read them backwards, like again, just to know what happens. So what does else mean? And what does if mean? So if means if the x value is 0 or more, which is if we're moving right, and that's it. But you're gonna see right away here, if I do a test, is what if I stand still? Stand still means it's gonna be 0, 0. So I don't want to do any changes, right? I want to just do changes when the move delta is actually left or right. So here the else doesn't make like the proper purpose here. So instead of writing else, we're going to do else if move delta that x is less than 0. So what this makes sure is if we're standing still, we have the x as 0. So we want to do nothing here. We just want to keep it however it was. So if we're going left and I stop, it's going to remain left. If I'm going right and stop, it's going to remain right. So it's going to only change whenever I'm over or under the 0. So that's exactly what we want here. And we can start testing this out by checking this here. If you look, if I click left, it's going to put it left. I remove my hand, right, remove my hand, left, 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 right. So that says it all. After this, we're going to do some checking. So this one requires some attention, like extra attention. So we've got ourselves a box collider, right? I'm going to go ahead and then open my amazing paint skills. It's way too bright, I know. So let's go ahead, and this is our player with the, okay, never mind. This is our player. Amazing. Let's go ahead and make it greenish. This is our player. And one of the ways of handling collision is raycasting. And I'm sure you've heard of it or maybe worked with it before. There's multiple ways of raycasting using the physics framework. Some of them they do raycast, some of them do circle cast, some of them do box cast, some of them do other stuff, line cast. Since we're using a box collider here, we're going to do what's called box cast. And what box cast is basically it casts a box collider in the direction that you're giving with the distance that you give, and of course with other variables like with interacting with specific layers, blah blah blah. So what's happening is, let's say we have some sort of like a line here, and we want to do a cast. I'm going to get a different color. So what's going to happen is I'm going to tell him that at this direction, let's say here, at this exact direction, cast the box. If there's anything in here, don't move. You cannot move at all to the right side. If there's nothing, you can move. So this will, the more you move, the more it's going to come here. So when it reaches a certain place, it's going to stop. So it's all depending on how far you want to put the box in order to make the game work. And this is, we're going to see it now in an example. So we have our player here. What's going to happen is we're going to cast it to the right side and check and then apply the movement. And the same way, so we're going to cast it to the left side, check and apply movement. Similarly to the y-axis. So first thing we're going to do is we need to have something called like something that stores the results of the casting, and it's called raycast 2D. You can put it in here and you can put it outside. What I mean by outside is in here if you want to use it in other methods than movement. But since I'm only using it in here, I'm going to keep it inside. Let's call it cast result. What I'm going to do is I'm going to initiated like here, so I put it here and then go cast result equals, since we're doing physics 2D, we're going to go physics 2D dot box cast. So as you can see, there's multiple stuff in here about box. There's box cast, box cast, all overlap box. You can read about all these stuff in the documentation, but we're going to use box cast because it's going to cast the first box that actually hits something, whereas box cast, it gets multiple stuff. If you want to access multiple things, you can use this one, but we're going to use this box cast. And we need to get through those stuff one by one. If it's a bit confusing, you just go ahead, go along with those stuff, because you're going to get used to what these things mean. If you don't know what origin does or what size does, you can always get to the documentations, but I'm going to explain them in slightly bit more detail but it should be fine. So first thing we need to do is we need to say from where do we want to cast, which is going to be our position. So I'm going to go ahead and write transfer position. And the next thing we need to do is we're going to tell them how big the box that we want to cast. I'm going to use the same size of the player's box, and it's going to be this one here, this box collider. So we need to access this one in here. The way to access it is we either can create it outside and then drag and drop it, or we can access it through the script. So I'm going to do it this way. Private box collider 2D, and let's call it box collider. You probably have wondered why I've put these ones. This is just a naming convention. I'm used to it. Usually you put a small letter at the start, but I like to put C because it's my first initial name. So I just put it an underscore, whereas the public ones you can just put them as like a box collider. This is just a common usage of what is it called? Fields and properties, but this is for something else right now. You don't have to worry about it. So we put the box collider here. You have two ways of doing this. Either you can put a serializable field on top of it, and it will appear in here, and just drag and drop it. Or you can use mono behavior to get it from our current game object. So let's remove this. I'll keep it. How can we do this is by, let's create a start method, which is made by mono behavior. It calls at the start of every, just once, every time the script is starting in the scene. So what we're going to do is z box collider and go get component. So it's going to get the box collider, and that's it. So this makes sure that we're fetching the box collider from our game object. So it's going and looks in here, where's the game object? This one, and then gets the box collider. Good. So now we have this set up. So if you haven't done this, you will run into problems. You will get null references. So that's been done, and we need to use the size of the box collider in this next field here. So here we're going to go box collider dot size. So what this means, we're going to spawn, or actually cast, a box that's the same size of our collider box. The next thing is angle. Since we're gonna do in one direction without, like, what I mean by we're not gonna rotate the player up and down, we're just gonna keep them like this. So going left and right. We're gonna go and put this as 0. So we're gonna ignore it. And the next one would be direction. It's gonna be quite intuitive because we're already getting the values in here, which is the move Y and X. And first of all, we need to check for the X-axis. Since we're going to check for the X-axis, we're going to go use a vector tool and then apply, what's it called, the move like X that we have done here. So it's going to go move X and ignore the Y because we don't care about the Y-axis for this check. And let's just reiterate again, we've got ourselves the move X here. Again, you can use move delta X or move X because again, X is part of move delta X. It doesn't make sense. The next thing will be is distance, and this is might sound a bit confusing, but it's not. So we told the script to cast a box from our position with the same size, and we told it which direction, so it's going to go either left or right. And now we're going to tell it how far does it go. We're going to use the same thing. We're going to use the move x, but we're going to have to use it in order in the same way that we want to move. So we want to apply the movement direction itself. So we're going to go ahead and go move x dot multiply by time the delta time. So what this does is it makes sure that we're going to apply the x value in the same direction for all the devices regarding of the frame rate of each device. Again, you don't have to get the detail of all these things if you get confused, but this is what it's used to move the player, so we're going to use it also for the casting direction of the box. But again, we want to make sure that we're going to cast in our direction that we look at. So if we're looking backwards and we click left, it's going to go look at the minus direction, so that's the wrong way. So we're going to always look, we want to look in front, because when you click left, it's going to flip the whole thing. So we can use something called absolute, which is quite a simple math thing, which is if you have -5 or 5, the result will be 5. It's going to make sure that the result is always positive. So we can go math if that ABS, sorry, and then put this stuff inside again. Last but not least, we got something called breakcast head, if you can see here, but we're not going to be using this one. We're going to be using something else, which is layer mask. Layer mask is we're going to tell this method, this action, which like layers you want to hit. So definitely we don't want to hit all the stuff. Let's say you made a casting to check if there's doors or there are weapons or there are enemies. So for this one, we're going to make sure that we're only checking the specific layers. So in our case, we want to check if it's blocked by something like doors, props, or even other players or NPCs. And for that, I think we have to do and create something new. Like right now, we've got a layer called player, right? And enemy, but that's not everything that we need. So we have to go and click add layer and add something called you can put floor and then wall, and then you can put props, but that's going to just keep on piling for you. So better to have one layer called block. Let's say block move, and this layer will make sure that never mind. Make sure that we don't have to put the whole other stuff on multiple things. Like we can put it on the wall, on the doors, or on boxes or other stuff that we don't want to get over. And again, we also have enemy, which is fine. Again, you can put one layer, call it characters, so we can bind them all into one thing. You can have enemies, you can have NPCs, you can have other players if you're making a multiplayer game. So that's not a big deal. It's all up to you. And how can we tell them, alright, just access these ones? There's an easy way of doing this is by accessing layer mask dot get mask. So what this does is it tells Unity get our mask of name blah blah blah, and then use it here, because layer mask is basically an integer, and you would ask what is integer. It's basically this number on the left side. So if you know the numbers, you can just put it here. Okay, box cast layer, here we go. So let's start writing, but let's say we want to interact with enemy and block move. I would like to point out something here. In every 2D physics system, the casting starts from inwards. What that means is it first checks internally and then goes checks outside. What this means is if you have put I would say if you put players in here, you want to check with other players, the player will not be moving because it's going to say, okay, I'm right now interacting with a player because it's myself. So in order to make sure that this doesn't happen, you have to go to the project settings, physics 2D, and then query starts in colliders. I think I disabled this before, but what this means is actually says that whether ray line cast start inside the colliders actually take colliders or not. So if you have this toggled on, make sure it's toggled off. So the player will ignore itself. That's been done. We've checked x-axis. Check if we are hitting something in the x-axis. How would we know that we have something? Since we've assigned this whole thing into the callcast, we have to check if callcast.collider. Let's say you can do other things. Like just keep it as it is. What this means is if it's not null, if it exists. So if it exists, stop moving on the x-axis. That's fine. So how do we do that? You see this apply movement. This is where this whole thing comes into work. So what we need to do is we need to go transform that translate, which means, as it says, move the transform in the direction the distance of the translation. Blah, 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 blah. So since we're going to move in the x-axis, we're going to have something here called x, y, and z. You see? Since we don't want to input the x, y, and z because we already have the move delta itself, what we're going to do is we're going to just segregate it by x, y, and z itself and then put it inside here. So we're going to go ahead and go click move, right move delta the x, then time the delta time, and then make sure the y and z are 0 because we're not going to apply anything in the y direction, and the z, of course, we're not going to do anything because it's a 2D game. Since we reached the place where we apply a movement, I want to make use of the movement speed. So first of all, let me just make it 1 by default. So this movement speed has to be applied in here because this is the last place, the final entry of the movement. So we're applying the movement in here, so we're going to put the movement speed here. I'm going to put it as 1 right now, but again, you can put it however you want later on. So we took care of the x-axis, right? Before testing it, I'm going to apply the y-axis. So let's just copy this whole thing and then paste it. Check if we're having anything in the x-axis. It's quite simple in the sense copy pasting. We're just using the same object, reusing it, and casting from our position and the same box size, but we're going to choose the direction of y, which is move y, and using the absolute value of move x, move y, the delta time. And I did forget something here, so I need to apply the movement speed here. So we've got this thing here, we've got the movement speed of the y, we get the layers, everything's set up, we get the cast glider, but here we have to make sure that we don't move in the y-axis. So instead of having this move y delta, the delta here in the first place, let's remove everything. Make sure the first one is 0, the second one is going to be the y, and make sure to name it y, and the z will always be 0. So we've written all this stuff, and it's a lot of things that we wrote, and hopefully it will work fine. So before we start, we just want to make sure that the movement speed is 1 because it's exposed in the editor. And if everything is fine, when I click play, if I click right, yep, something is wrong. Alright, so I did figure out the issue is because applying the movement inside the if statements in here is going to be a bit confusing. So what I did is, if we're getting anything triggered in x-axis, we just zero out the x movement, which means can't move anymore. And the same thing goes to the y. And afterwards, if whatever happens in here, we just apply the movement. And the movement can be applied by going ahead and clicking transform and translate move delta, which is basically the actual move vector that we assigned, multiplied by time the delta time and the z movement. And this can be really visible in here. So before we can test it out, I'm going to create, let's say, an example. Here we go. We have the enemy. Let's put the enemy here. Let's call it enemy. Give it a box collider. That's good. And let's play. So we can go left, right, down, up. And then as soon as we hit the enemy, it's going to stop in his track. And why that? It's because he's hitting something. So that's why it's happening when we get from the down up and the left and right. So with this we have our own movement system with a collision. I'm going to remove these stuff, keep it, save it all, and then we can change the movement speed to modify the speed of the move that we have. I think I have to do something here, call it fixed delta time, probably because we're using a fixed delta. I'm not sure, maybe it's going to do any effect, but it just makes more sense to use fixed delta time. And yeah, that's it. Now it's much smoother, the movement. I was realizing there's some snatching, but again, that's all about this one. So the next thing we need to do is handle the camera. And by the camera, let me just show you in here. Let's say this is our viewport, right? This is whatever we see inside the game. And our player is right here. Actually, let me just make it this way. Our player is right here. I'll make it like this. He's in the middle. So our player is right here. And I keep changing stuff. I'm not that good. Here we go. And we want to make sure if the player moves away to the right side, the whole viewport will move along with it. Let's say if the player moved here, we want to shift the whole area to the in order that the player will become the focus of the point of our viewport. And how to do that is we're going to use something called bounce. And bounce is basically it's like an invisible small viewport. Let's say it's this much, right? Let me do it this much. So it's in the side. Let's say it's this much. And it has a value of, let's say, 0.1 to 0.1. It depends on how big the screen, like from 0 to 1. This area is going to be 0.2, and then we're going to have the two values in the x and y. So as soon as the player moves outside of this, we're going to cause the whole viewport to shift towards that position, whether it's an x or an y position. And to do this, let's create a script. Call it camera. I'm not going to call it camera only because camera is used. I mean, camera controller. Okay, that makes more sense. And let's put it on the camera itself. Here we go. Let's make sure that we have the viewport. This is our viewport. And let's put the camera controller in here. Let's go inside. So the first thing we need to do is assign the variables and the methods. So the variables is we need to keep track of one thing and one thing at all, is the player. And how to keep track of the player is tracking the transform. So what we're gonna do is, instead of writing public, we can go private transform z player. Okay, and let's make it serializable field. The second thing we need to do, we need to assign the bounds of how far can the player go outside this invisible bound, and we can create a private float. We can call it bound, no, x bound, and the same thing will be y bound. I don't like the naming. I'm going to call it bound y. It just looks so weird. I'm going to bound x. I put them on the same line. I think it's better if we put them on separate lines because I want to give an initial value. Again, this value is depending on you. You can play with it however you want. So I'm just going to go ahead and make this one and the y. I'm going to make y 0.2 maybe. This is 0.1. It's because our game is landscape, so the distance on the x-axis is longer than this y-axis. So if you give it the same size, it will become a bit awkward. So I'm going to give it 0.2 to 0.1, and that's it. So now we're going to have to apply the logic. And as I said, there's a lot of updates we can use here. But the most appropriate one to use for camera is late update. Why? It's because this happens at the end of the update. So whatever we've done in the game, whether it's going to be a normal update, fixed update, this will happen right afterwards. So we make sure that whatever movement has been done is already done. So let's start by adding the logic here. So first of all, we need to do something like create a vector value that will be used to move the camera. Right, because we're going to have to use the transform, we have to store the value in something. And the second thing we have to do is basically zero the whole thing out. So I think creating the whole thing here will make sure that it's always resetting. And then we're going to have to calculate the offset of the player, how we can say offset according to the bound, right? So that means is we're going to see if the player went left or right or up and down. And then what's the best name to call it? Like it's apply the offset to the created move vector depending on the direction the player moved. So we've known the player went outside the bound, right? After this, we have to see if he went, or she, like whatever. If it went on the left side, we have to make sure that the bound will offset properly in the sense that it will reset back in the middle. So I'm going to make it look bigger. If this is my bound and my player moves here, I want to move the whole bound this way. So that's what it's all about. And then apply the move vector to the camera position. So let's start from the beginning. Let's make a vector 2D, call it follow delta, right? Let's have it this way, or move direction. It's easier. Let's make sure that it always comes back as 0. So whenever it's always resetting at the start at 0. And the first thing we have to do is we have to check if where did the player go. So we go if, since we have the player here, we go ahead if player, player, the player that position.x, so we can see if the player position is outside the bound, right? Oh my god, sorry, I got a scratching stuff. So we have to go ahead and then check it here if x definitely equals transform that position x. So we can have a huge condition here. So in order to make it look nicer, let's assign it here and let's call it delta x. And delta x is basically takes the player position and then how far did it go away from our camera position, because that's what we're going to check first. So we're going to put delta x and then we're going to put delta y, so we can use them later in the checking y, but in the delta y we're going to check the y position according to the player y position. So first of all we're going to see if the delta x, so the distance traveled from the player, from the original place of the camera, if it's bigger than the bound x, so that means it moved further than what it was supposed to do. But it's not just that one, we're going to make sure that if it went either way, left or right, so we're going to check if it's bigger or smaller, because it can become its minus. So we're going to go ahead and delta x is less than minus z that bound. So here we make sure that we catch the player if it goes sideways. So now we get the player movement tracked. We want to see if it's on the left side, move the thing to the left side. If it's right side, move to the right side. Right. How to get that is we have to check if the player is it this side or that side. And the way of doing this is checking the x position. So we have our position in the middle as a camera, and if the player moved to the right, I think for you it looks left. If the player moved this way, the x will increase, so that means the x is bigger, whereas this side, the x is smaller. So go ahead and make z player that x is bigger than transform that position that x. Oh, I think I have to write position. Position that x, the player is on the right side. Else, the player is on the left side. So when the player is on the right side, that means the value of the x has increased. So in order to reset the whole thing, we have to divide the offset. So to do this, we're just going to have to select the movement direction that we have here and go ahead, go move direction dot x, because we're handling the x value, and we're going to go ahead and delete delta x, minus the bound x. So we reset it in a way that it goes back to the same place. Whereas if it goes to the left side, that means the value became less, so we have to append the value in order to compensate the change. So x axis, so this is all handling the x axis. We're going to have to do the y axis. For the y axis, it's going to be quite simple because we can just change the names. So delta y, 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 y. Make sure that we rename everything properly. Here we go. We had a mistake already. Y, y, and y. And I'm going to move these things, make sure that, so if it's up, that means on the upper side or the lower side. Let me move my comments to put them here. Here we go. Here we go. And last but not least, so if you notice that we're applying the changes onto this move vector, because this is going to be the value that we're going to apply to the position of the camera. And what we do for the position is we go transfer the position, and we're going to go plus equals. What this means is add to the existing position of the camera. We're going to go ahead and write delta. No, actually, that's correct. We're going to write this one, move direction dot x, move direction dot y, and we want to make sure that we have this as 0. So we cannot just write the whole move as it is, because it's going to apply the z value, but we don't need the z value to change. So we need to make sure to assign the player first, because if we don't assign the player, and then we're going to have to access it here, we're going to get a lot of null reference. And again, I would suggest that you take all these stuff and put them here in a private method void follow player, and then paste it, and then call the method, because this will make sure that if you have any other stuff you want to add in here, they're not going to compile in the same place. It's going to become hectic. Okay, so we have our camera, we have our player, and we have our enemy. Let's go click on the camera, make sure that we drag and drop the player in here. Oh, I forgot to do something here, so let's have this also for the bound. Don't get confused. Why is it showing as 0? It's because if you set this up before you set this one up, it's going to come up as 0, so it's fine. So just make sure that you have the value here as 0.1 and 0.2. I think it's the opposite, 0.2 by 0.1. Let's remove these ones here. Keep them actually. Let's give it a test. So you'll see, like, if I start going left, the camera will start moving with the player. I'm going to put it inside, and you will see the camera here. You see it start to move with the player. Again, you can play with the values however you want. You can increase the size of it. You can say, okay, I can allow the player to move further. That needs to be like 0.3. So when you reach at the edge of the camera, the player can move like. If I put a 0.7, it's going to move when you start to reach the edge of the screen. Again, I like it to be slightly subtle, so let's have it as this one. This is good enough for us. So now we have ourselves a camera that moves with us and a collision system. I think that was quite dense for this episode, and then we've got good enough elements in our game that allows us to start testing. And I think in the next episode we're going to start building the level using the tile maps. But that's all for this episode. I hope you did not get confused as much as I thought it could be. And if you liked the episode, please hit the like and subscribe, and then I'll see you all in the next one. Adios!